At the greatest to start recording on here. I'll pull this up.
What happened yesterday with the
Oh, I don't know if anybody's watched it, so we'll see. We'll see what happens. Hopefully nobody just comes up to me and says something. Okay, so what's our first question say? Once we graph in Desmos, how long did it take for Jason to reach his maximum height? So if we want the maximum height, what point are we looking at on Desmos? That vertex, that highest point up here. Okay, so if you click on that highest point, you should get 0.5, 484. Yes? Okay, so t is time. Well, t in this case is x. So we have 0.5 for x. 0.5 what? Seconds. So it took Jason 0.5 seconds to reach his maximum height. But think about it, guys. Think about it. If I, like, say, well, I probably shouldn't say it on that. If I was standing on this desk.
Do it. You won't.
Okay. Say this is like, say this is like, and I'm going to jump. Like, you don't go, like, really, really high. Do you know what I mean?
Yeah.
So, like, it doesn't really make any sense that, like, it would be, like, 2 seconds or 3 seconds. It's going to be really, really fast. Yes? No. No. Okay. So, about 0.5 seconds is kind of reasonable. Okay, that kind of makes sense. What is the height at that highest point? What is the height? This is not wanting to work for me. What was it, 484?
Yeah.
Yeah, so we look at that y value, 484.
Is that feet?
Yep, feet. Okay, and then Jason hit the water after how many seconds? So if we think about a graph, right, or if I was to jump off of this table, right, and I land, we want to know where he lands, yes? So we need to know, where does our graph cross that x-axis? So if we go back to, okay, that's not what we're pulling. Okay, and we go back to our x-axis right here where it hits. Okay, now mine's really, really skinny. That's okay. Okay, it's 6 seconds. It hits after 6 seconds. You tracking with me on that?
Mm-hmm.
Okay. She must have gotten it. All right, number 2. Go ahead and put number 2 into Desmos. Okay, go ahead and put number 2 into Desmos. Okay. We can kind of zoom in a little bit more on this one. All right, we ready?
It's funny. Have you ever heard of that?
What, did I do something?
No, I did something.
Oh.
Not tiny.
Okay, so looking at our graph, looking at question A, how long will it take for the rocket to hit the ground? So I hope that you're getting this. Anytime we're hitting the ground or laying in the water or whatever it is, okay, that is when where our graph crosses the x-axis on the right-hand side. Are we getting that? Is that making sense? Okay. So that would be 8 seconds. Okay, part A is 8 seconds. B, after how many seconds will the rocket be 112 feet above the ground? Okay, that's a little tougher to find. What you can do, there's a couple options. You can say y equals 112. Okay. And what it'll do is it'll draw a line across your graph. And you can see where it hits 112. Well, by the question, it says, after how many seconds will it be 112 feet above the ground? The first initial time that it's 112 feet is when? 1 second. Okay. So you could put 7 seconds as well, but typically they're saying the initial height, okay, which would be 1.
1 second.
Okay, now I'm going to show you, 1 second. Okay, now I'm going to show you another way of doing this. Okay, you could actually, yep, table. You can go up here, press your wheel, press table, okay, and it comes here 1, 112. Now in that one you didn't see the 7, but I mean if you would make this bigger, you could do 3, 4, 5, 6, 7, okay, and you can see it there too. But either way, it's totally fine. Question so far? So this was 8 seconds. This was. Any other questions? Okay. How long will it take the rocket to reach its maximum height? So if we go to max height, 4,256. So they're asking how long, which is time. Yeah, 4 seconds. That's right. Okay. What is the maximum height? 256 feet. Very good. Jacob, did you say this is easy? You're already caught up from yesterday, aren't you?
That's all?
Pretty much. I mean, this is pretty much what we did, right?
Yeah.
The only other thing that we did was we basically drew it. Like we drew, because like if you look at the front, it has like the graph on it, so we actually drew the graph. But that's it. That's the only thing that's different. Okay. I know, Desmos is awesome. All right. Mine too. Don't tell Kevin. Okay. That was pretty funny. That was pretty funny. Yeah, we should all write Valentine's to the people at Desmos and send them to them.
Yeah.
What if he watches your videos? I thought it was good.
He definitely does not spend time.
Kevin, just want to tell you, this isn't gonna work out. No, this is not one of our students. It is Miss Crosses. I'm so sorry. I'm so sorry.
Well, it's gonna be like, why your voice really changed?
Yeah, I'm sorry. Got all the fire.
It reversed.
Reverse.
Oh, that's a hoot. Okay, part E. Is the rocket moving faster from 0 to 1 or from 3 to 4? What do you think? Okay. Now, why?
Went from 0 to 100 feet.
Okay, so if we think about it, 0 to 1 is probably like here-ish. Okay, 3 to 4 is like somewhere up here. Okay, so if we were to expand it like a normal graph, right, as it approaches the top, it's going to slow down a little bit. Yes?
Just like when something is going up.
So 0 to 1, because it is steeper.
We're trying to dunk a basketball.
Yeah, now we're going to dunk basketball.
Can't do that.
Okay, number 3, go ahead and put it into Desmos.
That's black lines.
Or am I doing better?
Oh. All right, group. Here we go. All right, that was a little bit better. Okay, so you are trying to dunk a basketball. You need to jump 2.5 feet in the air to dunk it. The height that your feet are above the ground is given by our function. What is the maximum height that your feet reach? What's the how high?
2.2.
2.25 feet. Okay, what does the 0.375 represent?
The time.
That's the time. Okay, so at 0.375 seconds, okay, you were 2.25 feet in the air. That's the highest that you got. Okay, so that's part A, 2.25 feet. Will you be able to dunk that basketball?
No, I don't know. Honestly,
My life. I try every day.
Friends, let's focus, please. We're never going to get this done if we don't focus. Okay, you have to jump 2.5 feet to dunk it, but you jump 2.25. Can you dunk it?
No.
No, that's too, right? You did not jump high enough. Sorry about it. That'll work on your ups a little bit, okay?
You have to put on there. Do that sad face too. Like,
I'll do it sounds good.
do that.
Okay, let's talk football. Okay, this is actually, I think this is pretty cool because I think it's kind of applicable when it comes to being a kicker. Okay, a football player attempts to kick a football over a goalpost. the path of the football can be modeled by your function, where x is the horizontal distance. So this is what I need you to kind of focus on here, because this one can get a little bit weird. Okay, x is the horizontal distance from the kick, and h is the height of the football. Okay, so h is the height of the football, x is the horizontal distance that you kick. Yes?
Yes.
Okay. Yes. So let's go ahead and put it into Desmos. This one's going to look a lot wider, FYI.
It already looks smart. Oh wait, what do you mean? Oh my god.
Because think about what a football kick looks like.
Wait.
You know what I mean?
How big that was?
Wait, what did I do?
Huh?
If you just hit the divided by button, just hit divided by.
Whoa. I did something weird. That is one. Yeah, I did something wrong. Whoa. It doesn't look like that. What did I do wrong?
That's unfortunate.
I did something wrong. I did too. Now.
Okay, make sure it looks like this. Okay, if you just hit -1 divided by 225, it should automatically make the fraction for you. Don't forget your x squared with that. It has to be x squared. No, you don't have to put we never put anything on the left side of the equal sign. It'll just complicate things.
But I checked the equation.
Oh, you
39, 44, 45, 45 and 21. I had some 8th grade stuff in my head. It's called Quadratics.
Oh, yeah.
I'm gonna sit down. You don't need water. You need water. Is that what it's called?
Yeah.
Oh,
Okay. Friends, go ahead and click at the very top where that vertex should be, and it should pop up for you. It should be 75, 25. Okay? Now, I want to talk about what these mean. Okay? The 75 is the x value. What does x represent again? Look at your notes. Horizontal distance. Okay, so if I was to kick a ball, okay, how far I kick it is 75 feet. Yes? From where it hits my foot to where it lands on the ground is 75. Cool? Okay. I'm sorry, that's not true. At 75 feet is where it's the highest. Yes. Okay. Over here, it went a total of 150.
Like how far away?
Yes, when it landed on the ground. So this is when it was the highest. Okay. 25 is the height of the ball. Okay, that's how high it got in the air. Yes? You with me?
Yeah.
Okay, part A, determine the vertex. Okay, so we don't need that yet. Determine the vertex. What's the vertex? Oh, right here, sorry. 75, 25, yes, we didn't do that. Okay. What does this mean in context? We just explained that, okay? So at a horizontal distance of 75, the ball was 25 feet in the air. Or you could say the ball was the highest point of the ball was 25 feet at a horizontal distance of 75. Whatever you want to say. Okay. So I'll type this out so that way we can.
Oh wait, no.
Okay. The goalpost is 10 feet high and 45 yards away from the kick. Will the ball be high enough to pass over the goalpost?
Yes.
If it's 10 feet high and 45 yards away, will it be tall enough?
Wait. The 10 feet high one is the one?
Hold on, man.
Yeah, 10 feet is wide.
No. Size measured in yards.
It's 45 feet.
Or yards, whatever it is, yards.
Whoa.
Okay, so 45 feet high, that's wide, right? Or 10 feet high.
It's 10 feet high.
10 feet high, so that's wide, right?
Wait.
Yeah, 45 feet.
No, I don't want to look at the point for this. Let's think about it realistically. If it gets up to 25 feet and at 75 feet, would it pass through at 10 feet, 45 feet? Yeah. It definitely would, right?
Yeah.
Yes.
Because like think about it, like we're saying it's like right here.
Wait, X is the.
It would definitely.
Yes, it would.
Yeah. Because it's highest. Yeah, because it's highest at 25. Okay. So that would be yes.
I'm sorry. Okay.
That's a very weird question. Okay.
Just
It's a very
just
weird
put-
question.
You just gotta put 45 in the table.
Well, the table's gonna look weird because it won't match up to 10.
You have to put the-
But you just have to look, is your vertex higher than this? Yes, it is.
Okay.
Oh, I'm sorry.
Okay, I think we only have a couple left. Okay, the manager of a company uses the function to model its daily profit based on the price of production in dollars. Okay, so let's talk about what this means. Okay, what does X represent?
The price of a product in dollars.
Price of a product. Okay, what does Y stand for here?
The other one.
What's the other one?
Daily profit.
Profit. Okay, so Y is profit. So they need a certain number of, their price per product needs to be calculated properly to make a profit. It makes sense. Any kind of business would be that way. Okay, so let's go ahead and put this into our Desmos.
No, it's okay.
Wait, so when it's going down.
Okay, it says, what is the minimum price? Okay, now, price is X or Y?
X.
X. So what is the minimum price to avoid a loss? So here's what I want you to think about. Profit has to be positive. Yes? What value is profit? Is it X or Y?
Y.
Okay, so would you agree that our Y values need to be on the positive side? Okay, so it can't go below the x-axis? Okay, so right here, to get a $0 profit, the price needs to be $22. That's the lowest the price can be, is $22. That means they would break even in their business. You tracking with me?
Yeah.
Okay, so the minimum, part A, the minimum price to avoid a loss, which is negative. Loss is down here, okay? Profit's up here. Okay, so it would have to be 22. Part B, what is the maximum price to avoid a loss?
37.
Yes, right? Loss is anywhere below the x-axis. So the maximum price is 53. It's a weird question. This is why quadratics are really cool, because we can use them in a lot of ways in real life situations. You just got to know how to read them right. Okay? Because we're talking about a loss here. Does that make sense? That's why we're not looking at the vertex yet. Part C. What is the price in dollars that results in the greatest profit? Where is your greatest profit going to be found if it's the y value? All the way at the top, the vertex. Okay, so I'm going to zoom out here. There you go. Okay, so it says, what is the price? Which value? Yes. Okay, the price is $37.50 for a profit of $204.25 for that day. That's what they make in that day. You track with me on that? Okay.
I'm proud of them.
So this was 22.53. 37. Okay, so as you can see, 5 and 6 are a little bit more challenging. We're going to do 6. Okay, this is definitely a challenge. All right, a rectangular park has an area of 250 square feet. The length of the park, okay, so this would be the length, yes. Okay, we'll call this the width. Okay, the length of the park is 7 more. If I said you have 2 Skittles and I have 7 more than you, what would you do to her 2 Skittles to get mine? Add 7. Okay, so when we say 7 more, we mean plus 7. Okay, so 7 more than twice. If I have twice as many Skittles, what would you do? Times it by 2. Okay, so we're going to say times 2. Okay, so 7 more than twice the width. So would you agree it would be 2W plus 7?
Yes.
2 times the width, add 7. Yes? Okay, so now it says, write an equation in terms of W to model this situation. So how do we find the area of a rectangle? Length times width. What is the area? Okay. And our length is 2W plus 7, right? Times the width, which is just W, right? Look at that. Okay. Now we need to rewrite this and get a quadratic equation. What am I going to do here?
You're gonna
Distribute my W. So I get 2W squared plus 7W. Okay, then I'm going to subtract my 250. So I have 0 equals.
Oh, so it's equal 0.
Yeah, because we want a quadratic equation. Okay, there's the quadratic equation. That is a challenge question. You won't be tested on something like that. Okay, but this is just another way. Like if they're working on parks and stuff like that, they'll use math like this to help them figure out different things. It's kind of cool. Okay, go ahead and work on day 2 practice. Okay, if you look, day 2 practice is just the rest of this page and one more on the next page. Don't do day 3. When are we doing day 3?
Monday.
Yes, and I will be here. I know it's going to be gone. I'm going to be here. Okay, so I'm here. You can check your work, right, at the very back. If you remember yesterday, all of the answers are here for the practice. Okay, so go ahead and work on that. You're in here for another 6 minutes. Jeez, it goes fast.
We're having fun.
Yes, we are. And your quizzes looked great. I will get the rest of them graded and put those in the grade.
I'm digging this one. I am digging your dynamite.
You know what's also forever for
You are the Triceratops.
I'm not digging your dynamite.
Oh, I have fun with that.
What was the first one?
I keep up for
All the other ones
Keep bringing it.